as you know, this meeting is recorded and will be uploaded to public internet. So watch what you're saying. Okay, guys, so we have a couple of items, given that tomorrow is the code freeze and also the fact that I will be on vacation for a while. Basically, starting tomorrow, I'm not going to be around for about 10 days. And I guess I have already mentioned that we're not going to have any meetings next week. It's going to be holidays here in the US, and I'm pretty sure very few people will going to be around. So no meetings next week. We are going to finish up everything that we have probably today or tomorrow, since tomorrow is going to be the code freeze. I know that there are a couple of issues which are not like super urgent, but there are some issues that we would still like to fix in 1.13. I guess both of the ones that I have in mind are being handled by Wei. One is a crash in the scheduler, which is actually a rare kind of crash, but it happens occasionally. We don't know exactly why it's happening, but we still need to fix it. It's apparently caused by the fact that some of our pointers are nil and we dereference them, and it causes a crash in node info clone function. So we need to address that and merge it in 1.13. We can merge bugs after code freeze, but it's still better to merge as soon as possible so that those dot releases will have the patches. That's one. The other
for this one, for this one, I think we can have a safe fix like you comment in the issue, so we can just check the resources whether they are nil and guard on that.
Yeah, I actually didn't carefully check, but looks like we always create node info with the new node info function, and new node info function always initializes those resources. So I cannot think of a scenario where those resources are nil, but apparently it happens somewhere, and we still need to check. I guess probably a better approach to the problem is to make sure that every time that we initialize a node info, we do it via the new node info function, not directly.
Yeah.
Probably there is a direct initialization, I would assume, somewhere in the code, and it's probably a path that is not very commonly executed. Otherwise, we would have seen a lot more crashes.
Yeah, exactly.
Okay, so we can actually, I didn't look carefully. We can actually look a little bit more carefully. Maybe we can find it. But anyways, regardless, I guess it doesn't hurt if we add those checks. Probably they're not going to make us slower compared to, relative to what we do in the scheduler and all the logic, there are probably several more checks that are not going to hurt us much. Okay, that's one. Another issue that Wei actually did a great job finding is sort of like a race condition in the preemption logic, so that sometimes when a nominated pod is being rescheduled, the fact that it's nominated is removed from the scheduling queue. So the scheduling queue, while looking at the pod or retrying to schedule a nominated pod, doesn't have the information about the fact that this pod is nominated. So when the pod goes back to queue, let's say that a nominated pod is not schedulable, so it goes back to the queue, and the scheduler actually picks another pod from the queue. But in the meantime, where this is being put back to the queue and another pod being scheduled, the scheduler may miss the fact that there is one extra nominated pod. As a result, the pod that is being tried after this nominated pod may be considered schedulable and getting scheduled, and then later on gets preempted again by the high priority pod, basically, that with the same nominated pod. So this race condition can be fixed by basically leaving the nominated pod information in the queue until the pod is actually assumed. So Wei has that fix. He is working on a test. He has actually written a pretty sophisticated end-to-end test for this, which can reproduce the issue. But the test is brittle, in my opinion. It counts the number of events happening for pods and stuff like that, which is probably going to fail in the near future by change of logics in many places in the code. So I asked him to see if he can reproduce this with an integration test. Of course, since this is like a race condition and it's kind of rare, it may not be reproducible all the time, but if we can reproduce it with some probability, I don't know, 5% or so is enough. And then when we have the fix, we can check if it is still reproducible or not. So, Wei, I guess I asked you this on the bug.
Yeah.
I don't know if you have tried stress testing this, with actually running the test with stress, maybe for 1,000 times or something, to see if it fails.
Yeah, I have tried a little bit this afternoon, but I just don't have luck to reproduce it using the integration test. So basically, every time the preemptor has the chance to be rescheduled prior to other pending paths, and the first time it got the chance to be rescheduled, it has the chance to be scheduled, to be running on the path. So no other story after that, right? So I think why it happens in the real world is that the preempted paths are still being terminated, so in their grace period. So that means in the first attempt to reschedule the preempted path has failed because the resources has still be kept by those terminating paths, right? But in the integration test, I don't know why. There is a comment maybe by you says that we must set the grace period to 0. Otherwise, it won't be work or something like that. So I tried, yes, I have to set the grace period to 0. And that means all the paths will be preempted immediately.
Yeah, no, you don't need to. I guess that the graceful termination period equal to 0 was for a different test. In this particular test, you can increase it. It should work. Maybe we didn't want to unnecessarily wait or make the test slow in some other cases, but feel free to increase it. Probably like 1 or 2 seconds would be good enough for your case, right?
Yeah, I tried to add some seconds, but it seems it totally doesn't work. I mean, the preemptor wasn't able to be scheduled, so I haven't checked the real case yet. But I will do some more investigation to see whether I can build an integration test.
Okay, sounds good. Among other changes that other folks are working on, is there anything that requires attention or requires my attention in particular? Is there any major or critical change that you want to merge into 113? Okay, I assume.
So Bobby, so for these 2 issues, I should be able to give a final commit by tonight, I think. Okay. So you are still available tomorrow, right?
Yeah. I will be on vacation starting tomorrow, but
sorry.
Tonight I can check, or tomorrow morning I can check. I mean, it's not a big deal. You can ask Klaus to approve for you, or actually I can approve them, and then you can ask someone to LGTM.
Okay.
Hey Bobby, I had a question about the issue which I had raised, which was like time-based priority heap, the active heap which is being constructed. So like we have a lot of like people who are submitting machine learning jobs, so they just fire and forget jobs, but they're long running jobs. Almost all of them are. So it's like a big issue for them. Like if there are 5 jobs waiting, obviously because the resources are being consumed, all the GPUs and everything. Right. So when their jobs are being picked up, if they don't get picked up by time-based order, like it's a big issue for them, because then people which are submitted a job like 2 days back, their job gets picked up because some of the jobs run for days. So what was the blocking condition you were talking about? Like I was trying to review it and I have posted a comment on what scenario I try. Yeah. So we were just wondering what was the blocking condition you're talking about?
Yeah. So the thing is this, in our scheduling queue, if you've noticed, there are like two queues, right? So one is the unschedulable one and one is the active queue, right? So when a pod is tried, it goes to the unschedulable queue.
Yeah.
And once a condition changes in the cluster, the pod is moved from the unschedulable queue to the active queue. So in larger clusters with thousands of nodes, let's say, the events that we receive for nodes are very frequent because nodes send updates every 10 seconds.
Yeah.
Right? So basically, let's say that if you have a thousand nodes in your cluster, chances are that you receive on average 100 updates per second.
Yeah.
Right. So pods in the unschedulable queue go frequently to the active queue.
Yeah.
Right. So if you have let's say a pod that is unschedulable and keeps getting to the head of the queue, it can block the other pods behind it from getting scheduled. Because if it is created in the past, it just keeps going to the head of the queue.
Yeah.
So that's the blocking thing that I'm worried about in larger clusters. I saw your comment there. Sorry, I just saw it right before this meeting. I didn't have the chance to reply. But I guess in your case, since the clusters are small, probably you don't see this issue, right? Because this pod that is in the unschedulable queue is not going to go very frequently to the active queue.
Yeah, but without that condition, don't you think it's all random anyways, the chance? So anyway, some of the pods are going to go in pending state. So at least like what we were thinking is like, at least we can determine how the pods are getting there. I understand the issue, but what if people need the pods to arrive? And
right now, if many pods have the same priority, some of them are already in the active queue.
Yeah.
And when you move something from the unschedulable queue to the active queue, chances are that those which are currently in the active queue are going to be ahead of this pod.
Yeah.
Right. So those get some chance to be tried by the scheduler.
Yeah. So what we were trying to replicate this scenario is like we had a lot of jobs which are long running jobs, and in most of the cases, the job which was next was never picked up. Like it was always like if there were like 4 jobs running, you expect the 5th job to get picked up, and we made sure the resources were present for the 5th job. 9 out of 10 cases, the 7th or the 8th job got picked up. Like not so we were wondering like, even if you say that's an issue, maybe we could put that as a flag. But the logic is like just few lines. So if you put a flag where people really need in order of like execution, and they could use that flag, and your priority queue could handle in order arrival of pods in that case. If that would be really helpful.
Yeah, we can certainly do that. And I mean, if a flag that is maybe by default disabled for now at least. We can certainly do that, or a config somewhere that tells the scheduler that it could be like a policy config or something as well. But we need some sort of a configuration, because otherwise, in some of the scenarios, this may hurt performance of the scheduler.
Okay, sure. I'll update it to work with flag and then send the PR. Sure.
Yeah, sounds good. Another thing that actually has been in the back of my mind for a long time now is the fact that we shouldn't be retrying all these unschedulable pods very frequently. We should have a backup mechanism, basically. And in the past, without the priority queue that we currently have, we had a backup mechanism. So if we tried a pod and it was unschedulable, we would add a little bit of backup, and the backup would get incremented like exponentially up to a certain limit. Like for example, before we would increment it up to a minute. Minute is too long. Maybe if we can increment it up to 10 seconds or something would be would be good enough for now. Actually, there has been a PR for a long time now to implement the backup mechanism. But I guess the person who was working on that PR is no longer active.
I know him.
Okay.
Yeah. I know him. He's in the same team of me, so maybe I can talk with him. Yes, I can talk with him, picking up his stuff and continue on that.
Oh, that would be great, because I was kind of on the verge of cloning his PR and finishing it myself. If we can still work on it, that would be great.
Yeah, I can talk to him. Yeah.
Okay, sounds great.
Greg, right? Greg.
Yeah, Greg.
Yeah, he's in Knative community.
Oh, okay. Yeah, if he can still work on, I think it. I actually, last time that I reviewed that PR, I felt like it's almost there. I had some comments about changing some smaller things, if I'm not mistaken. It was long back. I don't have a very good recollection of that. But I feel like it was almost there. And probably with a little bit more work, it would have been done. But anyway, if we had that backup mechanism, the problem that we are now talking about, like a pod kind of hugging the head of the scheduling queue, wouldn't have been there. I mean, the scheduler would have tried several times, and then this pod would get a back off and wouldn't be put into the active queue after like several tries. So it would have waited a little longer, allowing other pods behind it to get scheduled. And if we had this backup mechanism, probably we didn't even need to have any flags or anything. We could just sort everything by priority, then by creation time. So I'm aware of this. I'm aware of the fact that this is actually a feature that a lot of batch jobs require.
Yeah.
And we want to try to address this actually in the scheduler as well as in our pod creation logic. This is actually something that we sometimes refer to as queue jobs. There are jobs that are queued and should be scheduled based on the order in the queue, right?
Yeah.
Another thing with these jobs, sometimes probably you don't have a lot of concerns about coda.
Yeah.
But some users which run multi-tenant clusters have concerns about coda as well. So you have like queue jobs, and you don't want these queue jobs to consume your coda if they shouldn't be scheduled. For example, if you have a job that should get scheduled and finished, and then the next one should be scheduled, you don't want all of those to use all your coda from the very beginning.
Yeah, that is one of the concerns. Like, we have spoken to Klaus about that as well, and we were trying to figure out how is he going to manage that in Kubernetes scheduler, because like certainly if you're running machine learning jobs, there are users who do not get a chance to submit their jobs ever, and that's a big headache for us as well.
Right. Actually, today I spoke with one big company. I cannot reveal the name, but you all know, probably the largest company, at least in terms of market cap in the world. So those guys are switching from Mesos to Kubernetes, which is actually a good news for us. I met with their scheduling team today, and they are probably gonna start contributing a lot of code to us, to Kubernetes, and particularly to scheduling. Those guys are also interested in some of these features, and in particular, some features around batch. Kubernetes is already a pretty good platform for running services, but when it comes to batch, we still need quite more features for batch scheduling and batch admission.
Yeah.
So this queue jobs is certainly one of those. We are gonna start adding more features, particularly implement queue job, and then later, and maybe not necessarily later, and in parallel, maybe also work on gang scheduling.
Yeah. The one concern which we had was what was the direction going forward? Is Kubernetes going to be an alternative scheduler, or there are plans to integrate that into the default scheduler for future releases?
But with Mike, according to the conversations that we've had with Klaus, the plan going forward is to build this scheduling framework, and then after prototyping gang scheduling in an incubator, which is Kubernetes, we bring the logic and everything as plugins for the scheduling framework. So, but whether it's going to be one scheduler or two schedulers is something that we need to discuss. It's not finalized yet, but at least today our plan is to build everything in the same code base.
Yeah, because some of the people have started using Kubernetes and default scheduler, and one thing which they have noticed is like when two schedulers are competing for resources, some of the APIs don't like behave appropriately. Like they both are assigned a node, and then one has a memory unavailable or something, and they just back off. So that's another concern which we were going to look after this one gets solved. Like when two schedulers are competing for the same resources, I don't know how they are going to manage that, but
that is true. So that's kind of inevitable, or sort of inevitable in scenarios where you have multiple schedulers, and if both of them are very aggressively looking for resources, for example, if both of them have a lot of pending pods, then chances are you will see this problem. This is probably less common in clusters where there are not a lot of pending pods, or you have a lot of free resources available. This situation probably happens with lower probability, but in well utilized clusters, this is a common issue. So for that, we may actually, the reason actually that I said that we haven't decided is exactly because we haven't experimented with these two scheduler scenarios enough to tell you whether we should go with a single one or two works reasonably well.
Okay.
Okay. Is there any question, comments? Oh, Harry is here. Harry, how are things going in the equivalence cache world?
Hey, yeah, I have some quick updates. So as I mentioned last week that I encountered some issues during the POC code, and I spent a whole week on it, so I think the issue has been fixed. So next week, I can create a issue of a task list and contribute some PRs based on, I think the first PR will be the cleanup PR.
Okay.
And yeah, and feature PR will follow behind that.
Nice. That's great. Okay. I mean, probably you've seen I have actually created a cleanup issue for you.
Oh, really? I did not notice that.
Okay,
I will check.
Yeah. I created a cleanup issue to remove equivalence cache from the scheduler code.
Yeah, that's my plan.
Yeah. Wei and I were wondering whether we should let Wei do the job or you have the cycles to do it. So
yeah, I was assigned to Harry.
Okay, that's good.
Okay, so Harry, you're fine with Wei taking care of it, or?
Okay,
I think he will. Maybe I think he will take care of it, right?
Sorry, say that again. I didn't hear you well.
I think Harry would be in favor of taking care of it.
Sure. I don't have any particular preference. If any of you has enough cycles, I'll be happy to give it to any of you guys. So Harry, you're gonna do it yourself?
Okay, I will do that.
Okay. Yeah, the issue is there. We've mentioned you, I guess, in that issue. You can probably find it. Okay, what else? I guess these are all the things that I have in mind. I would like to emphasize again that next week we are not going to have any meeting. By the way, are you folks going to KubeCon this year? Or Seattle?
I'm going to.
Okay.
I will be there. I have a small talk over there.
Oh, nice. Okay. How about you, Ravi? Are you going? Or Suresh? Any of you folks going?
Yeah, I'll be there.
Okay.
No, I'm not.
You're not.
I'm going to my native country.
Okay. So I guess I see most of you folks in KubeCon as well. All right. Thank you so much. we are almost running out of time. If you have any question, comments, last minute, you can share with us.
Okay, thank you.
Thank you, guys.
Thank you.
Thank you.